This is part 2 of the resistance reflection rule derivation. In this part, I'm going to show the equivalent resistance seen at the emitter now. So to do this again, a test source is placed at the emitter. This time I'm going to use a voltage source, which I call V test, and now I need to solve for I test. So the current through here is going to be V test over RE, because I've set this voltage to V test. The current through this branch is going to be, again, V test divided by RB plus R pi. And I'm desirous to find I test. So if I sum all of these currents, I have I test in, GM-VBE in, V test RE, and V test RB plus R pi going out. So I test is going in, and GM-VBE is going in, and V test over RE is going out, and V test over RB plus R pi is also going out, and that's equal to 0. So now I need to write VBE in terms of V test or I test. In this case, it will be easier to write it in terms of V test. So VBE is going to be a negative because this is plus to minus and this is minus plus, so the polarity is opposite. So a minus V test over RB plus R pi, and multiply that by R pi. And then I can plug that back in here and get an equation for I test, which will be a plus, so this goes over to the other side. So I get a plus V test over RB plus R pi plus a V test over RE and then the GM becomes a negative, so it becomes a positive on the other side. So a V test times R pi over RB plus R pi, and this also is multiplied. This is just VBE right here, so I need to multiply it by GM. Again, R pi and GM are related by beta over GM, so this becomes beta, and I note that I have the same term here, so this will become a 1 plus beta. So I test will be equal to 1 plus beta V test divided by RB plus R pi plus V test over RE. Now, the R equivalent is going to be V test divided by I test. So V test over I test will eliminate the V test, so it will look like 1 over 1 plus beta over RB plus R pi plus 1 over RE. Now this looks like the equivalent RE in parallel with RB plus R pi over beta plus 1. So our equivalent is RE in parallel with RB plus R pi over beta plus 1. So this looks like the equivalent of whatever's in the resistor or in the emitter resistance. And because I'm finding it at this and this is in parallel, That's why they're in parallel here. And then I have RB plus R pi over beta plus 1. So when I'm looking in at the emitter side, I leave the emitter resistors alone. And all of the base resistances, I divide by beta plus 1. So at the base, divide all of those resistances by beta plus 1.